Hello, and today we're going to talk a little bit about batteries. Now, I'm going to go through and talk a little bit about the construction of various types of batteries. Then I'll go into talking about the chemistry that's going on within those batteries. And finally, we'll talk about some advantages and disadvantages of a particular battery compared with the others. So to start things off, I want to talk about alkaline batteries, or the more typical AA batteries that you'll see at the store. Um, Now, the way that these are constructed is that in this kind of purple area, they have zinc powder mixed in there. And basically, this is what is going to be providing the electrons within our battery. And it's connected to this essentially metal nail that goes through and connects to the negative terminal. So, so with this negative terminal, basically what happens is you'll have that connected to your device. It comes up, and then from your device, it will come and touch the positive button or the positive terminal at the top of the battery. Now, this positive terminal is connected to essentially a metal container or a steel can, and this will serve to function as our cathode. Now, this cathode, if we follow this along here, it's actually touching or interacting with our true chemical cathode, which is our manganese oxide. And so this is what's going to be essentially consuming those electrons. So there are a couple other things going on within this battery. One of the big things is that almost all batteries have some form of a separator, uh, designated by this gray area here. And basically what that does is it allows the battery to complete the circuit, kind of like the function of a salt bridge, without having the chemicals mix directly with each other and essentially causing your battery to discharge without you actually utilizing it. And then most of the other things are just kind of like this plastic cover here is just kind of help keep everything separated so they don't touch. Now, a little bit about the chemistry that's going on in here. We start off with our solid zinc, and that'll interact with OH minus and will produce our electrons. Then we have our reduction reaction, where we have the manganese oxide along with a little bit of water, taking in those two electrons to form Mn2O3. Then what we can look at here is that we can see that in the oxidation reaction, we can add up all of our reactants so that we can form an overall reaction. And one of the things that you'll notice here is that this one is producing two electrons, and our reduction reaction is consuming those two electrons. And so we can just add these together in a 1-to-1 ratio. So we can bring down our zinc, we can bring down our MnO2, but then we can say, all right, the OH minus is being consumed here, but it's also being produced in the reduction reaction. So in a sense, it's a little bit like a catalyst. Then we can have our water that is being consumed here, but then also being produced there. And so when it's all said and done, all we're left with is our zinc plus manganese oxide is forming zinc oxide and Mn2O3 for the overall thing. Now, if we add together our standard oxidation and standard reduction potentials to form the standard cell potential, what we get is the standard cell potential is 1.43 volts. Now, this can actually be adjusted or tweaked a little bit, so we can get up to 1.5 volts. A lot of times this is done through changing the concentrations a little bit, and that's how you can kind of adjust the final voltage of your battery. So one kind of interesting thing here is, so you'll notice that we have this 1.5 volts that is being produced here. Well, for your normal 9-volt battery, this is simply AA batteries hooked up, so you have 6 AA batteries in series. And since they're hooked up in series, all their potentials add together, and that's where we get that 9 volt from. So if you ever see one of those kind of larger, kind of a little bit larger in their hand, 9 volt batteries, if you ever go through and essentially dissect that one, you'll see that oftentimes it's filled with a whole bunch of just normal AA batteries inside it, which is kind of interesting. So some of the advantages of alkaline batteries is that they have a longer shelf life than dry cell batteries, and they're reasonably inexpensive. Some of the disadvantages are that basically they're just not rechargeable. You can recharge your AA batteries a little bit, but for the most part, it doesn't necessarily go that well, or won't be able to stand the test of time. Eventually, your reactants will essentially leak out of the battery a little bit, and it won't be good anymore. All right, so next type of battery I want to talk about is a dry cell battery. Now this is very similar to your AA batteries. You can actually buy dry cell batteries that have the same size as AA. But this is probably one of the most simple types of batteries. So for this one, we have our zinc, similar to last time. We have our zinc here shown in this red, and this is connected right to our negative terminal down here on the bottom. So it can go from our negative terminal, the zinc is providing the electrons, it travels to our device, and then going from our device, it goes back up to the top, where we have our positive button. And this positive button is connected to a carbon rod. This is basically serving the function of an inert electrode. And that allows it to essentially complete the circuit to this purple area here, where we have manganese oxide, along with a couple other things, but this is where our manganese oxide is. Now, to keep those from interacting too vigorously, we actually have this separator here, right between both the zinc and the manganese oxide paste. And again, this serves the same function as a salt bridge. So to go over a little bit about the chemistry that's going on in here, let me go ahead and erase all my little drawings. And we can see that we have our zinc providing the electrons, we have our manganese oxide taking up the electrons, along with the ammonium ion. And we can essentially add these together, and we get an overall cell potential of 1.5 volts. So kind of one of the interesting things with this particular type of battery is that if you're ever in need of an inert electrode, you can actually go through and buy some dry cell batteries, and very, very carefully, if you can open it up, you can actually take out the carbon rod in there, and that can serve as a very nice inert electrode. All right, to go over some of the advantages, the main advantages to the dry cell batteries is that they're very inexpensive. Kind of the main reason why they're not used more is because they don't have a long shelf life. But they do work well in various weather settings as well. A couple of the main disadvantages is that one, it's not rechargeable, and they actually have a short shelf life. That's kind of why the standard AA batteries, the alkaline batteries, that's why they are more prominent than dry cell batteries, is basically because of the shelf life. So the third type of battery I want to talk about is a nickel cadmium battery, which is a rechargeable battery, or known as a secondary battery. So kind of the way that this thing works is that we have a whole bunch of essentially anodes and cathodes all hooked up together with a thin separator in between. So this is normally referred to as a jelly roll. And so we can have, like I said, this alternating positive and negative cells with a thin separator in between them, and they just have a whole bunch of them all hooked up together. Now, the way this thing actually works is that we can have our essentially negative electrodes they're down here. They're attached to the bottom portion of this battery. So that connects them to the negative terminal. You can go through, connect with your device. After your device gets powered on, it will connect back to the positive button on the top. And this positive button is now connected to all these positive terminals, or positive electrodes, shown here in the blue. So you'll see that they're just slightly off-centered from each other. Now, the reason it gets the whole jelly roll name is because if you kind of look at this kind of cross-section, it looks a little bit like what you'd expect for a nice pastry of sorts. So to talk a little bit about some of the advantages, or sorry, to talk a little bit about the chemistry that's going on here, as the name implies, we have some cadmium, which is actually producing our electrons. Then we have some nickel oxide, which is consuming the electrons, and we end up with an overall cell potential of 1.2 volts. Now, some of the advantages and disadvantages to a nickel cadmium battery. Some of the advantages are it says rechargeable. That's probably one of the big advantages to it. And it's actually a fairly cheap rechargeable battery. And they have a very long shelf life. So some of the disadvantages to it is that they actually have a very low capacity, and they actually have, you can't recharge them indefinitely. So each time you recharge it, it's going to not quite charge as much as it did the time before. So typically you have about 1,000 recharges or so for them. So nickel cadmium batteries are typically used for things like power tools and electrical toothbrushes, things of that nature. Things that only need a little bit of power to operate at the time, and then you want to be able to recharge them later on. All right, and then the last type of battery I want to talk about today is the lead-acid battery. Now, for a lead-acid battery, this one's kind of interesting in the fact that it kind of is designed a little bit similar to the last one we looked at, where we had that jelly roll thing going on, where we have alternating anode and cathodes, and they're essentially set up in series in order to get a very high voltage, and they're all sitting in this liquid here, which is sulfuric acid. So I'll talk a little bit more about this in a second, but let's go and talk about some of the chemistry involved here. So for our oxidation, we have lead solid that is producing our electrons when it's coupled with HSO4 minus. And for our reduction reaction, we have lead oxide. And this is interacting with HSO4 minus plus some acid, so essentially sulfuric acid. And this produces lead sulfate. Now, one of the interesting things about this, why it makes it such a good rechargeable battery, is that both of our half reactions have the same product. They both form lead sulfate, or lead sulfate and essentially water. So when we are using this battery, we'll go ahead and draw up our little battery here. All right, now our negative terminal, our positive terminal. All right, so we're going to have electrons flowing from our negative terminal to our motor, or we could say to our starter of our car. And this will cause the motor to turn over and get the engine running. And when the battery is operating in this instance, we have the forward reaction going as it's drawn here for the overall reaction. But after you get your car started, your battery's essentially drained a lot of its potential, or a lot of its power that it can use, and then this is hooked up to an alternator. And the alternator in your car essentially uses the engine to generate electricity, essentially a little mini generator, and it's going through and is supplying electrons to the positive terminal, whereas before we had electrons coming from negative terminal.
And as it's providing electrons to our battery, or electricity to our battery, it's able to cause the reverse reaction to happen. So it's able to convert all this lead sulfate back into solid lead and lead oxide. And so we're able to essentially recharge our battery and get us back to where we were before we ever started our car. And so that's one of the reasons why this is so useful. We don't have a lot of different side reactions that can occur. And so it's actually a pretty reliable recharging apparatus. So one of the main advantages to the lead acid battery is that it's rechargeable. All the materials are fairly inexpensive. And probably one of the most important ones is that it's a very rugged battery. It can take a beating and still keep on working. So it can sit in your car engine and it's vibrating a lot, and you hit a pothole or something, it's still going to function. You don't have to worry about it essentially breaking down. Some of the disadvantages to it, though, is that it has a very low energy density, meaning that for the given area of the battery, it doesn't have a lot of energy to provide. So essentially, it's enough to kind of start up your car about 1 to 3 times, and then it's essentially out of juice. And this results in it being fairly heavy for what it does, or the amount of energy it can provide. All right. So hopefully you found this lecture interesting, and I look forward to seeing you next time.